Welcome to our presentation of assignment 2 Pac-Man Capture the Flag. During the presentation, we will show our strategy design, challenge experienced, possible improvement, and demo videos. In the final version, we use a strategy of combining approximate Q-learning and heuristic search algorithm and game theory. We created a lot of new features and balanced weight. And we use heuristic search algorithm and game theory to avoid type position. Firstly is our strategy design. We use a two offensive agent and we cover a lot of scenarios such as distributed food, avoid enemies, going home, chasing opponents, avoid dead corner, and avoid type position. This is how we generate our feature value. We generate the minimum distance to off left food using H and heuristic reduction method. Distance to the closest active scared host, distance to the closest capsule, best safe distance to the home entrance, best safe distance to the enemy entrance, binary feature, whether faced a dead corner. The next part is the challenges. We have faced a lot of challenge. The first challenge is that we have to choose the strategy between two offending agent and one agent. The second one is the type position problem, how to get into the enemy region and how to find a safe way going back home. The third one is facing dead end, how to avoid a dead alley and how to avoid a corner. The last one is that the go back home timely, when to going back, where to achieve and how to achieve. According to the game theory, we balance the winning rate of two offensive agent and one agent. Finally, we combine these two techniques and we choose two offensive agent with defensive strategy.
Heuristic search algorithms solve the problem more quickly and have a large probability to find an approximate solution. We today start in pathfinding because we don't consider the cost of every state generation. And approximate Q-learning simplifies the problem, and we use handcrafted intelligent features rather than update weights, and there's no need to memorize each state, and it saves memory space and computation time to compute the value of each state. Here is a comparison of two offend and one strategy. We can see that the average score of two offend is higher, but the winning rate is lower. So considering different opponents, we considering the different components, we made a game using these two strategies, and we could see the average score for two offend is much higher than the one strategy. The future improvements are as follows: a better entries to enemy region, a better cooperation between agents, such as better assigned food, better timing to eat capsule, and more precise dead alley detection, avoid internal problem. And the last one is a better strategy to chase opponents, whether to quit chasing or whether and how to cooperate. This demo shows the first bit for our problem. If the agent goes to a dead end for avoiding the opponents, it will goes into a result that never goes back. The second one is the agent stay in enemy regions for too long, even if it carries a large amount of food, which is not an optimal solution. The third one is the agent falls into a tight position, which means the agent will escape from the opponent and find it safe and there remove forward and find it danger and then escape and so on. This is a demonstration of two offense strategy. At the start, the agents choose different heuristic foods according to the upper foods and below foods. And then after each one foods, they starting to choose the max heuristic value of foods. And when they facing a ghost, it will determine if there is a capsule. If there is, it will go to capsule and try to chase the ghost, and it will escape from the not scared ghost and chase the scared ghost again. Of course, we would avoid entering to a dead end and tries to eat other food and return home timely. And when the time is running out, it will try to go home, and when facing time position, it will choose another path going back home. This is a one strategy. One of the agents will go to eat foods and another one will defend the territory. The defender will gets the position of the opponent agents and chase it until kill it. And another agent will try to eat food in the enemy's territory and escape from the chase of the enemy. And it will go back timely. The defender is patrol in 3 position, and it's the most possibility to get the enemy in the territory.